Welcome to the Data Genius podcast. Today, we are taking a deep dive into the massive shift happening in human resources and recruitment thanks to AI and agentic workflows.
Yeah, it's a huge topic.
It really is. You know, looking through the stack of research and articles you provided for us to analyze, it becomes incredibly clear that for decades, applying for a job felt like, well, folding a paper airplane, tossing it into a literal black hole, and just hoping the wind caught it right.
That's a very accurate way to describe it.
Right, because you would send your carefully crafted resume off into the void of some corporate HR department and, wait for a human being to eventually pluck it out of a stack of thousands.
If they ever did.
Exactly. But stepping into the world of modern talent acquisition, that black hole isn't empty anymore. It is populated by this massive architecture of algorithms reading your resume, listening to your voice, and literally calculating your exact mathematical probability of success before a human ever even knows your name.
Yeah, the structural redesign of how companies build their workforces is just, it's complete at this point. I mean, the industry has moved entirely away from early automation.
Look, the old keyword scanners.
Right, exactly.
Right.
Where a rudimentary software program simply sorted keywords. We are now examining environments where AI actively orchestrates the entire hiring life cycle, making, contextual decisions at speeds humans just cannot physically match.
Which brings us to our clear mission for today's deep dive, tailored specifically for you as our listener. Whether you're a job seeker trying to figure out the underlying mechanisms of these algorithms so you can actually survive the screening process.
Which is getting harder every day.
Oh, absolutely. Or, maybe you are an HR professional examining how these systems compress your administrative overhead. Or, frankly, if you are just fascinated by the intersection of AI and the future of work, we are going to reveal the unseen forces shaping hiring today.
There's a lot to uncover.
We're going to unpack everything from the architecture of multi-agent digital interviewers to the strict mathematical legalities of algorithmic bias. But to understand the solution, we have to quantify the sheer scale of the problem. When we talk about traditional HR, we aren't just talking about a manager conducting a few interviews.
No, not at all. Traditional HR is fundamentally an impossible math problem.
How so?
Well, it is a data processing crisis operating at a volume that human cognitive bandwidth was never designed to handle. Consider a standard enterprise organization opening a mid-level role.
Okay.
They are not receiving 20 carefully tailored resumes. They are dealing with thousands. And across the enterprise, sometimes millions of applications annually.
Billions, wow.
Right. So the traditional bottleneck was never the human-to-human interview itself. The bottleneck was the sheer logistical nightmare of sourcing, filtering, cross-referencing, scheduling, and communicating with that massive ocean of data.
So they were basically just doing data entry.
Exactly. HR teams were essentially operating as highly paid data entry clerks and logistics coordinators.
Yeah.
They spent their days managing administrative friction rather than evaluating human talent.
Okay, so looking at your source material, specifically a really detailed breakdown from Interview Box, it maps out this transition into a very specific 5-stage AI hiring pipeline. And it is astounding how much of this funnel has been entirely abstracted away from human control.
It really is.
Let's walk through it. Stage 1 is AI sourcing. And I assume this is a massive leap from a recruiter just typing like Java developer into a LinkedIn search bar.
Oh, yeah. The shift here is from literal keyword matching to semantic search and predictive modeling. In the legacy systems, if a job description required, say, people management, and a candidate's resume listed team lead.
Which means the same thing to a person.
Right. But a Boolean keyword filter would mathematically score that as a zero match and discard the application. The system was totally blind to context. Yeah. But modern semantic search maps words into high-dimensional vector spaces. It understands the conceptual relationship between words. So it mathematically calculates that a team lead encompasses people management.
Okay, so it actually understands what you did, not just the words you used.
Exactly. And furthermore, predictive matching flips the sourcing model entirely. Instead of waiting for applicants, the AI actively analyzes the digital footprints of passive candidates.
Meaning people who aren't even looking for jobs.
Right. People not actively looking. By calculating variables like their historical career trajectory, the average tenure of people in their current role, regional compensation bands, and even company performance metrics, The model predicts who is statistically most likely to be open to a recruitment message right now.
Oh, wow. So it's actively hunting for talent based on a statistical probability of them wanting to leave their current job.
Yes, it's very proactive.
Which leads into stage 2, AI screening.
Mhm.
This is where automated resume parsing takes that massive initial pool and ruthlessly filters it down based on contextual matching.
Yep.
And then we hit stage 3, which honestly feels entirely sci-fi to me. AI interviews. We are talking about asynchronous video interviews where the candidate is talking into a camera, or even live conversational AI that speaks back to you in real time.
The critical mechanism to understand during those interviews is that the AI is not simply recording a video file for a human recruiter to watch later.
Wait, really? The human doesn't watch it?
The human might never watch it. The AI is applying natural language processing, or NLP, to transcribe your verbal answers into text in real time. It then structures that text against a predetermined competency framework, grading the semantic density and relevance of your responses against the exact criteria of the role.
That is wild, which feeds directly into stage 4, right?
Yeah.
AI assessment.
Yes.
Where the system administers proctored coding tests for software engineers or complex situational judgment tests for project managers, culminating in highly structured mathematical scorecards. And finally, stage 5, offer management. The system generates the actual offer letters, initiates the background checks, and triggers the entire onboarding and provisioning process autonomously. It is a completely automated assembly line.
To really grasp the gravity of this pipeline, we have to look at the Unilever case study from your notes.
Right, the consumer goods giant.
Yes, they handle 1.8 million applications a year for about 30,000 hires.
1.8 million, that's just, I can't even fathom that number.
Processing 1.8 million unstructured documents manually is a logistical impossibility without sacrificing immense quality. You would require an army of recruiters doing nothing but scanning pages for like 6 seconds each, 24 hours a day.
So Unilever completely redesigned their funnel. They partnered with a platform called Pymetrics to deploy gamified cognitive assessments. And according to the research, their legacy psychometric tests were so tedious, stressful, and poorly designed that they suffered a 50% candidate dropout rate.
Yes.
People were literally just closing their browsers halfway through the test.
Well, the dropout rate is a direct reflection of cognitive fatigue.
Right.
Traditional multiple-choice personality tests are highly susceptible to candidate manipulation. I mean, people just click the answer they think the company wants to hear.
Right. I'm a perfectionist.
Exactly. And they induce severe test anxiety. So gamification replaces that friction with neuroscience. Candidates play short, interactive digital games.
Like video games.
Essentially, yes. But the AI isn't looking at whether you win or lose the game. It is capturing thousands of behavioral data points per millisecond. It measures how quickly you click, how you react to a sudden change in rules, or how you balance risk versus reward when presented with a digital wager.
Wow.
Yeah, it elicits much more authentic subconscious behavioral data that correlates strongly to cognitive traits like memory, attention, and risk tolerance.
That's incredible. And then the candidates who matched the baseline cognitive profile for the role moved on to higher view for the asynchronous AI video screenings. And the results of this architecture are staggering.
They really are.
By combining the gamified assessments and the AI video screenings, Unilever saved 70,000 interviewing hours. They saved £1 million annually, and they shifted human review exclusively to the very final stages of the funnel.
It's a massive efficiency gain.
But this brings up a massive structural question for me. Processing 1.8 million applications manually is like trying to drink from a fire hose with a coffee stirrer.
That's a good way to put it.
I understand the logistical necessity, but if the AI is doing all the sourcing, all the screening, all the initial interviewing, and all the cognitive assessing, aren't we just stripping away the humanity? Like, if a candidate is nothing but a series of vectors and data points on a digital scorecard, where is the human in human resources?
The data presents a fascinating paradox regarding that exact fear. By utilizing machine learning models to mathematically filter 250,000 top-of-funnel applicants down to a highly qualified shortlist of, say, 3,500, the architecture actually preserves human focus for where it matters most.
Wait, so by keeping the human recruiters completely isolated from the massive top-of-funnel noise, you're saying they actually become more human?
The industry term is administrative compression. Think about it. If a human recruiter is tasked with manually screening 250,000 resumes, the reality of that process is a 6-second visual scan per document.
True.
There is absolutely no humanity, no empathy, and no deep evaluation occurring in a 6-second scan. It is a purely transactional, rote task that is highly vulnerable to subconscious human bias.
Like rejecting a highly qualified candidate simply because they attended an unfamiliar university?
Or because the recruiter is experiencing decision fatigue at 4:00 p.m. on a Friday.
Exactly.
When the AI handles the high-volume filtering based strictly on documented competencies and behavioral data, it eliminates that noise. The recruiter is then given the gift of time.
Oh, I see.
They can spend a full, unhurried hour having a deep, nuanced, meaningful conversation with the finalists. The objective of the AI is not to replace human connection. It is to automate the logistics, so human connection is actually possible at scale.
Okay, I understand the logic of administrative compression. You automate the friction to prioritize the final interaction. But how exactly are these systems executing these tasks? Because when the average person hears AI right now, they picture, a large language model. They picture a chat interface where you type a prompt and it generates a text response.
Like drafting an email.
Right, a draft email, a block of code, a summary. But these HR systems are actively scheduling interviews, interacting with candidates across SMS, and triggering complex background checks. That requires a massive leap in capability.
It does. It requires a fundamental shift in the underlying architecture. We are transitioning from the era of generative AI into the era of agentic AI. Grasping the distinction between those two frameworks is essential to understanding how these modern pipelines function.
So the source material from Fountain breaks this evolution down brilliantly into 3 distinct layers. Layer 1 is content generation. That is your standard generative AI. It drafts the job description, it generates a polite rejection email, it suggests a list of interview questions.
Yep.
It is entirely passive. It just outputs text based on a prompt.
Right.
Layer 2 is decisioning. This is where the models begin scoring, ranking, and classifying the candidates based on data. But layer 3 is where the paradigm shifts entirely. Layer 3 is execution. This relies on agentic orchestration, a framework detailed extensively by platforms like Findom and SS&C Blue Prism.
Yes. Agentic orchestration abandons the rigid linear constraints of traditional software. This is not a hard-coded script. It is not an if this then that macro where a bot simply clicks a sequence of pre-programmed buttons.
Okay, so what is it then?
Agentic architecture utilizes continuous feedback loops and autonomous cognitive reasoning. In these systems, you deploy an orchestrator AI and assign it a high-level goal. For example, schedule interviews for the top 10 candidates.
Just a broad command like that?
Right. Exactly. The orchestrator dynamically formulates a plan and delegates subtasks to specialized agent AIs. Those agents go out and execute the tasks. Crucially, the orchestrator evaluates the results of those actions in real time.
What if something goes wrong?
If an agent hits a firewall or a step fails, the orchestrator does not crash the system. It reasons through the failure, revises the plan, attempts a different tool or API, and continues working toward the goal.
The fascinating part to me is how these platforms are deploying this architecture. They are actively assigning these specialized AI agents human names and distinct functional personas.
It makes them more approachable, yes.
Fountain, for example, utilizes a full suite of these digital workers. They deploy Anna, the AI recruiter, who autonomously conducts voice and SMS text interviews 24 hours a day, dynamically adjusting her questions based on the candidate's real-time responses.
Amazing.
Then they have Emma, the AI support agent. Her entire objective is to clear document blockers. If a candidate attempts to upload their identification for a background check and the file format fails, Emma instantly reaches out, explains the error, and guides the candidate through the correction.
Right, without human intervention.
Exactly. And then there's Sam, the AI satisfaction agent, whose objective runs entirely post-hire, tracking employee retention, checking in on their onboarding happiness, and flagging potential churn risks before the employee quits.
This architecture relies on a critical operational boundary highlighted by NetSuite, known as the dynamic between escalation and completion.
Escalation and completion.
Yes. These autonomous agents are engineered with strict confidence thresholds. They either successfully complete a task, such as parsing a candidate's email, determining their availability, and locking in a calendar invite. Or they hit a barrier they cannot solve, at which point they escalate. But the escalation is highly sophisticated. They do not just dump a generic error code into a recruiter's inbox.
Like error 404.
Right, none of that. They provide a synthesized contextual briefing. The agent essentially communicates, I attempted to schedule this candidate. I parsed their availability and offered 5 corresponding time slots. The candidate rejected them and requested a weekend slot, which my parameters do not authorize me to grant. I have attached the full semantic reasoning and the chat transcript. How would you like me to proceed?
Oh, wow. So, to conceptualize this, it's like a hospital triage system. The orchestrator is the intake nurse. It handles the scraped knees and the basic logistics, routing the patient through the standard protocols. It only pages the expensive, highly specialized human doctor when it encounters an anomaly or a complex trauma it isn't authorized to treat.
That analogy maps perfectly to the resource allocation models these companies use.
Yeah.
And because these digital triage systems operate at the speed of compute, they're inducing a fascinating new friction in the labor market.
Friction, how so?
Research from Medix AI indicates we are witnessing the emergence of an algorithmic arms race.
An arms race.
Yes. On the employer side, you have armies of AI agents autonomously screening, filtering, and interrogating. On the candidate side, job seekers are increasingly deploying their own AI agents to autonomously mass apply to thousands of job postings, dynamically rewrite their resumes to match specific job descriptions in real time, and even generate live text-to-speech answers during video interviews.
No way. So it's bots talking to bots.
You essentially have AI candidates battling AI recruiters, with the machine learning models on both sides rapidly evolving to outmaneuver the other's detection systems.
It is genuinely a machine versus machine battleground happening quietly inside corporate HR departments. But, deploying this level of multi-agent architecture sounds incredibly complex, computationally expensive, and frankly risky to roll out across an entire enterprise.
Looking at the actual return on investment, are these digital systems actually delivering on their promises, or is this just theoretical engineering hype? The financial and operational return on investment is fundamentally altering the unit economics of enterprise business. The case studies indicate that when agentic AI is deployed with proper architectural guardrails, the workflow compression is unprecedented.
Let's break down the mechanics of that ROI, starting with a case study from CodeBridge. They built a platform called Recruit AI for a massive U.S. tech enterprise. This company was bleeding resources. Specifically, they were burning through 200 to 400 hours every single month of their senior engineers' time just manually reviewing and grading technical coding tests submitted by applicants.
It's incredibly expensive time.
Extremely. So CodeBridge built a multi-agent system utilizing a framework called LangGraph. This architecture allowed different specialized AI agents to handle the code execution, the syntax review, and the logical grading. It compressed their overall time to hire from 24 days down to just 10 days.
Massive improvement.
But the detail that completely derailed my train of thought was how the system handled the candidates who were actively trying to cheat.
Ah, yes, the invisible text tactic.
Yeah. Wait, white text on a white background. People still do that.
Oh, they try. This is a primary weapon in the algorithmic arms race. Candidates realized that legacy applicant tracking systems, the old keyword parsers, were incredibly easily manipulated. A candidate would copy the entire text of the job description, paste it at the bottom of their resume, and change the font color to white.
So a human can't see it.
To a human recruiter quickly glancing at the PDF, the page looks completely normal. But to the rudimentary parser reading the raw text layer, the resume suddenly appears to contain every single required keyword, generating a 100% perfect match score and forcing the candidate to the top of the queue.
But the Recruit AI multi-agent system caught it instantly, because it wasn't just matching keywords. It was analyzing the structural integrity of the document. The system utilized metadata analysis and statistical text analysis. The sources mention it specifically looked at the burstiness and perplexity of the text to flag the cheating.
The mathematics behind burstiness and perplexity are the core of AI detection. Human writing is naturally bursty. Yeah, a human will write a short, punchy sentence. Then they will follow it with a long, complex, highly structured sentence containing multiple clauses. The lengths and structure burst, and very unpredictably. Generative AI, by default, writes with very low burstiness. Its sentence lengths and structures are highly uniform and mathematically predictable.
Interesting. And perplexity.
Perplexity measures how easily the model can predict the next word in a sequence. If a section of a resume has extremely low perplexity and zero burstiness, the agentic system flags it as synthetically generated. Furthermore, if the system detects a massive block of text containing perfectly uniform keywords hidden in the metadata, it immediately flags the document for manipulation.
And to manage the compute costs of doing this deep statistical analysis on thousands of resumes, they utilized a hierarchical LLM model. They routed the simple, easy tasks, like parsing a phone number or checking formatting, to cheap, lightweight AI models. They only invoked the heavy, highly expensive models like GPT-4 for the complex logical code analysis. That specific routing architecture cut their API cost by 40%.
That hierarchical routing is the only way to achieve sustainable scale. Processing every minor data point through a massive frontier model is financially ruinous. IBM demonstrated a similar mastery of scale with their dual approach to AI deployment. On their internal operations side, they built Ask HR, an agentic virtual assistant designed to handle employee inquiries.
Okay.
In a single year, that system processed 11.5 million internal interactions, achieving a 94% containment rate.
Wait, containment rate meaning that 94% of those 11.5 million interactions were resolved completely autonomously by the AI without a human HR representative ever needing to intervene.
Precisely. The system autonomously generated employment verification letters, processed complex parental leave requests, and parsed regional tax policies to answer employee questions. That single deployment compressed IBM's internal HR operational costs by 40%.
40%, that's incredible.
And they mirrored that success externally with Watson Recruit. They completely abandoned keyword sorting in favor of the predictive matching models we discussed earlier. By mathematically matching candidate capabilities to role requirements, Watson Recruit saved IBM $107 million in a single year, while simultaneously tripling their applicant conversion rate from 12% to 36%.
Saving $107 million in administrative overhead is staggering. But the case study that really demonstrates the macroeconomic impact of this technology is McKinsey & Company. The global consulting giant deployed 12,000 AI agents alongside a proprietary generative tool they named Lily.
Lily, right.
This tool was designed using a retrieval augmented generation architecture, or RA. It allowed their consultants to instantly retrieve and synthesize decades of historical firm knowledge, case studies, and data points in seconds, rather than spending dozens of hours manually searching internal databases. The downstream result: McKinsey reduced their global staff by 5,000 employees, while simultaneously shifting 40% of their massive revenue stream into AI-related advisory services.
We see that exact magnitude of workflow compression in the banking sector with Flowable. They analyzed a wealth management bank struggling with their statement of work due diligence. This was a highly regulated, intensely complex compliance process.
Sounds slow.
It was. Human bankers had to manually cross-reference client PDFs against legacy database risk matrices and regulatory guidelines. The manual friction was so severe that a single review took 40 to 45 days.
45 days just to review a document.
Yes. Customers were infuriated by the delay, resulting in a 28% churn rate, meaning more than a quarter of their clients abandoned the bank during this waiting period. Flowable engineered a 28-agent architecture to divide and conquer those specific friction points.
How did that work?
One agent specialized in extracting PDF data. Another agent cross-referenced the risk matrix. Another handled the compliance checklist. By parallelizing the cognitive work, the processing time plummeted from 45 days down to just 1 to 2 days. The customer churn rate instantly dropped below 1%.
The efficiency gains are undeniable. But let's pause on the McKinsey data point for a moment. They deployed 12,000 digital agents and reduced their human headcount by 5,000. When you combine that with a bank compressing a 45-day human workflow into 48 hours via autonomous agents, it paints a very stark picture of global job security. Are we entering an economic reality where enterprise companies can scale their output and increase their revenue infinitely without ever needing to scale their human headcount again?
The macroeconomic anxiety is entirely justified, but the strategic application of these tools reveals a slightly different trajectory. The primary objective for these enterprises is not the absolute eradication of the human workforce. The goal, again, is administrative compression.
Right, removing the busy work.
Exactly. Machine learning provides the highest return on investment when it accelerates logistical friction and augments human talent. By automating the rote, repetitive friction, like formatting hundreds of PowerPoint slides at McKinsey or manually verifying compliance checkboxes across disparate PDFs at the bank, the enterprise frees its most expensive asset, its human capital, to focus exclusively on judgment-heavy, complex, strategic interactions. The total headcount may contract in purely administrative sectors, but the economic value generated by the remaining human workforce is amplified exponentially.
So the human energy is reallocated from data entry to strategic judgment.
Precisely.
But automating these enterprise workflows isn't always as clean as analyzing text within a beautifully designed API. Sometimes the most significant bottleneck in HR automation isn't the AI's cognitive reasoning, it's the AI's visual perception. The hardest part is often just getting the automation to successfully navigate and click the correct buttons on a clunky, outdated government website. Which brings us to a massive technical breakthrough in how AI interacts with digital interfaces.
The collision between cutting-edge AI and legacy digital infrastructure is a massive pain point. Historically, this is exactly where traditional automation frameworks have shattered, particularly within the highly regulated space of HR compliance.
The research highlights the hidden nightmare of HR operations, government portals. We are talking about running E-Verify for I-9 forms, managing background checks through third-party vendors like Check, and interacting with dozens of different state licensing boards, all of which use completely different, archaic website designs. Our source material from Skyvern details the fatal flaw in legacy automation, which they call the selector problem. What exactly is a selector, and why has it been such a catastrophic bottleneck for automating these compliance workflows?
To understand the bottleneck, you have to understand how legacy automation sees a website. In traditional robotic process automation, or RPA, a software bot does not look at the website visually. It navigates by reading the underlying document object model, the HTML code.
Oh, just the code.
Yes. It relies on specific markers in that code, called CSS selectors or XPath expressions, to locate the exact position of the submit button or the first name text field. The bot is essentially memorizing a highly specific, rigid set of coordinates buried within the code.
So it's completely blind to what the website actually looks like on a screen. It's just following a rigid map, executing a command like scan down to line 400 of the HTML and execute a click on the element labeled button A.
That is the exact mechanism, and it is disastrous when interacting with government portals because those state and federal websites are constantly updating. They change a field name in the back end, they completely redesign the graphical layout, or they dynamically generate an unexpected key PCHA for security purposes.
And then what happens?
The moment that underlying HTML structure changes, the rigid map is useless. The traditional RPA bot goes to line 400, fails to find the exact string for button, and the entire automated compliance workflow instantly crashes. It fails silently, requiring a human software engineer to go in, diagnose the failure, and manually rewrite the XPath script for that specific website. If an enterprise is trying to automate background checks across 50 different state licensing boards, they are trapped in an unwinnable, incredibly expensive game of whack-a-mole.
It is the architectural difference between a blindfolded person following an exact memorized number of paces to walk across a room versus someone who simply opens their eyes and visually sees that someone moved the couch. If the couch is moved 2 feet to the left, the blindfolded bot crashes into it and the system fails. The agent with its eyes open simply processes the new layout and walks around it.
That spatial awareness is exactly what the technical breakthrough achieves. Companies like Skyvern are abandoning DOM parsing entirely. They are pairing large language models with computer vision to create vision language models, or VLMs. Instead of relying on the fragile back-end code, the AI model is trained to visually perceive and process the rendered screen exactly the way a human user does. It analyzes the visual layout, identifies a rectangular box situated next to the text submit, and uses contextual reasoning to understand its function.
So if a state licensing board updates their portal overnight and the submit button moves from the bottom left of the screen to the top right, and they change the color from blue to red, the AI doesn't crash. It just visually scans the new layout, understands the new spatial relationship, and clicks it.
It adapts visually and contextually in real time. This structural resilience means a single generalized multimodal workflow can autonomously navigate E-Verify, CheckR, and all 50 wildly disparate state licensing portals simultaneously without breaking. Because it processes visual data, it can even interpret and solve dynamic PTCHAs, or process 2FA authentication prompts visually, maintaining continuous operation.
And the implications of that visual resilience for an enterprise HR department are massive. Because if a legacy automation system breaks silently due to a portal update, you could theoretically have hundreds of new hires slipping through the onboarding pipeline without proper background checks or E-Verify submissions being completed. That exposes the entire organization to severe legal liability, massive federal fines, and catastrophic failed audits. By shifting to computer vision, the system removes days of expensive developer maintenance and guarantees an unbroken, legally compliant chain of operations.
The focus on legal compliance is critical, because allowing autonomous AI architectures to run your hiring pipeline and mathematically evaluate human beings introduces a terrifying minefield of regulatory and legal risk. The legislative environment is desperately attempting to regulate technology that is evolving faster than the laws can be written.
The regulatory landscape is arguably the most complex environment in the history of enterprise software. The research outlines several massive legislative frameworks globally that are completely dictating how these models can be deployed. You have NYC Local Law 144, the Illinois AI Video Interview Act, and the absolute heaviest hitter, the EU AI Act. Let's examine the European Union's approach. In February 2025, the EU instituted a strict outright ban on emotion recognition systems in hiring. Legally, an AI model is forbidden from analyzing a candidate's facial expressions or vocal microtremors to calculate if they are confident, enthusiastic, or honest.
The European Union enacted that prohibition because the underlying data science of emotion recognition is fundamentally flawed and inherently biased.
Biased how?
Well, an algorithm trained on neurotypical data might mathematically interpret a neurodivergent candidate's lack of eye contact as deception, or it might penalize a specific cultural difference in physical expressiveness as a lack of enthusiasm. The technology was essentially generating digital phrenology, assigning deep psychological traits based on superficial physical measurements. The EU determined that the risk of systemic discriminatory harm far outweighed any potential efficiency gains.
And even if you strip away the visual analysis, just processing raw text data can violate federal law if the mathematical output fails the standards set by the Equal Employment Opportunity Commission in the U.S. This is known as the 4/5 rule, or the 80% rule. Schema AI's auditing documentation details this standard heavily. Can you explain the specific mathematics of how an algorithm fails a disparate impact test?
The 4/5 rule operates as a strict statistical baseline for fairness, regardless of the algorithm's intent. Let us say your AI screening tool is evaluating thousands of applications. If the model advances white male applicants to the interview stage at a rate of 40%, but it advances black female applicants at a rate of only 15%, the model is mathematically non-compliant.
Walk me through the math on that.
You calculate the impact ratio. 15 divided by 40 equals 0.375. Because that ratio falls below 0.80, or 4/5, the tool fails the federal fairness standard. It automatically triggers a disparate impact investigation by regulators. The critical factor is that the law does not care if the discrimination was intentional or simply a byproduct of the mathematical weighting. The statistical outcome is all that matters.
Which introduces the terrifying reality of the black box problem. A candidate receives an automated rejection email stating, "We have decided to move forward with other candidates." But in reality, the AI system mathematically calculated that a different candidate had a 3% higher probability of success based on millions of hidden data points from historical hiring patterns. And the truly alarming part is that sometimes, due to the complexity of the neural network, even the software engineers who designed the model cannot fully reverse engineer exactly why the AI rejected that specific individual.
That absolute lack of explainability is legally and ethically untenable when making employment decisions that affect human livelihoods. To mitigate this liability, enterprise systems mandate a specific architectural safeguard known as human in the loop, or HITL.
Human in the loop.
Yes. The protocol is strict. The AI is authorized to score, rank, and suggest candidates based on its analysis, but a human being must review the data and sign off on the final hiring or rejection decision. The system is hard-coded to never issue an automated rejection without the explicit possibility of human oversight. Implementing that single operational checkpoint reduces potential compliance violations by roughly 40%.
But there is a glaring logical flaw here. If the machine learning model is trained on a company's historical hiring data, and historically that specific company has had highly biased hiring practices employing predominantly people of a single specific demographic, aren't we just utilizing massive computational power to perfectly replicate and automate our own human prejudices at an unprecedented scale?
That is the most dangerous vulnerability in machine learning. If you feed a neural network biased historical data, it does not magically cure the bias, it optimizes it. It becomes a highly efficient, mathematically precise bias engine. This is why explainable AI frameworks are mandatory. The developers must program the model to be explicitly feature blind. The algorithm must be mathematically forced to ignore all demographic data, names, ages, genders, zip codes, and evaluate candidates strictly on documented verifiable skills.
But is that enough?
Not always. Even then, the model might secretly discover proxies for bias. For example, mathematically downranking candidates who played a specific collegiate sport that correlates heavily with a certain gender. To combat this, platforms conduct rigorous quarterly algorithmic audits. They feed the system thousands of mathematically identical synthetic candidate profiles, varying only the demographic variables, to rigorously test if the system's output remains perfectly impartial.
So we have incredibly sophisticated multi-agent architectures, strict mathematical baselines for compliance, and rigorous quarterly algorithmic audits running in the background. But let's ground all of this theoretical architecture into actionable reality. What does this paradigm shift mean for you, the person actually trying to find a job in this market right now? Because the rules of the game haven't just shifted, they have been completely rewritten. How do you tactically survive an algorithm?
The most important realization for a modern candidate is that the strategies that yielded success 5 years ago are now actively detrimental. Your first audience is no longer a human being. Your first audience is a resume parser, a natural language processing model, and a predictive matching engine. You must engineer your data to be perfectly digestible by those systems.
The documentation from Interview Box provides a highly specific, tactical guide for optimizing your output for these systems. Let's break down the resume screen first. Rule number 1, utilize the exact semantic tokens from the job description. Do not try to be creative. Do not rephrase. If the job description specifically requires agile project management, do not write that you were a Scrum facilitator.
Right, don't risk it.
The semantic search model might be sophisticated enough to map the conceptual relationship, but why risk the mathematical penalty? Feed the machine the exact structural tokens it is programmed to identify.
Rule number 2 is structural formatting. The architecture of your document is critical. Utilize pristine, mathematically clean formatting, eliminate all tables, remove all complex graphical columns, and absolutely never attempt to utilize invisible white text to cheat the system.
Like we talked about earlier.
Exactly. If the resume parser cannot easily extract the raw text layer because your data is trapped within a complex graphical element, your OCR, optical character recognition, fails. The machine assigns you a score of 0. You are not rejected because you lack the qualifications. You are rejected because your formatting broke the parser's ingestion logic.
And rule number 3, quantify everything with hard data. Writing reduced customer churn by 18% over Q3 generates a mathematically higher relevance score than writing a vague statement like improved customer retention. The predictive models require hard data points to calculate your probability of success. But what happens when you successfully navigate the parser and advance to the AI video interview? How do you tactically ace an interview when the interviewer is a neural network?
You must rely entirely on structural compliance. You have to utilize the STAR method: situation, task, action, result. Remember, the AI's natural language processor is literally grading your verbal response against a highly structured, dimensional competency framework. If you ramble or weave a complex, nonlinear narrative, the NLP cannot map your words to the scoring rubric. You must serve your experiential data in a perfectly structured, mathematically logical sequence.
And crucially, look directly into the camera lens. Do not look down at the screen and do not look at your notes. Even though emotion recognition is banned in jurisdictions like the EU, models deployed in other regions can and will track your eye contact patterns and facial telemetry to calculate an engagement score. You also must ensure your physical environment is optimized. Perfect lighting and flawless audio are non-negotiable.
Audio is huge.
If your microphone is muffled and the AI's transcription engine cannot accurately parse your audio, you lose points. It does not matter if your answer was fundamentally brilliant. If the NRP transcript outputs unintelligible, your data density drops and your score plummets.
That concept of data density is the final tactical imperative. If the AI allocates 3 minutes for a response, utilize the entire 3 minutes. When a candidate provides a brief 30-second answer, they are physically starving the algorithm of tokens. The NLP model requires a minimum threshold of semantic vectors to accurately map your answer to the competency grid. If you stop talking early, you simply lack the data density the AI requires to complete its mathematical analysis. You cease to exist on the scoring matrix.
It is a profound irony. It sounds like you are no longer interviewing for a job. You are taking an oral standardized test graded by an incredibly strict, mathematically precise robot. To prove your human worth, your creativity, and your potential to an enterprise, you first have to optimize yourself to be perfectly digestible to a machine learning algorithm. You have to strip away the human nuance and present yourself as a highly structured data packet.
It is the ultimate paradox of algorithmic hiring. You must perform exactly like a machine in order to prove that you are a highly valuable human being.
Which brings up a final, lingering thought for you to mull over as we wrap up this deep dive. If these AI architectures successfully execute their ultimate goal, completely removing all human bias by ignoring visual appearance, ignoring regional accents, and ignoring diverse backgrounds, and instead they predict performance with absolute, pure mathematical precision based exclusively on historical success patterns, what happens to corporate culture? Do enterprise companies eventually synthesize into sterile monocultures of identical, hyper-efficient worker profiles? If an algorithm is mathematically constrained to only hire the statistical ideal, do we permanently lose the brilliant outliers, the eccentrics, and the unexpected human innovators who just don't fit the training data? Next time you are sending your resume out into the world, remember you aren't just folding a paper airplane and tossing it into a black hole anymore. You are constructing a highly optimized data packet and firing it directly into a neural network. Make sure your edges are mathematically sharp. Before we go, please take a second to like the episode, leave us a comment sharing your thoughts on how AI is shaping the future of your career, and make sure to subscribe so you don't miss any of our future deep dives. Stay curious, and remember, the data never sleeps, but it's up to us to dream.